Okay, guys, today we're going to talk about reactivity and bonding. I just want to kind of recap what we've learned so far. First of all, if you have not done the basic chemistry vocabulary activity, do that because it has a lot of terms and things that are important with this unit. Okay, now also you should have watched the video and taken the notes on the periodic table and information you can learn about the periodic or from the periodic table, and hopefully you have color coded your periodic table and numbered and labeled everything on that. And then also you should have watched the video and on how to determine the protons, electrons, and neutrons for an atom using the periodic table. Okay, so if you've not done those, if you've not watched those videos and taken those notes, do that first before watching this video. All right, so this video is all about reactivity and bonding of different atoms, of different elements. So let's go ahead and get started. Remember, you want to have a highlighter, and hopefully you've printed off the note sheet and you're ready to fill that in as we go. Okay, so first of all, reactivity. So react. Okay, what happens when you react? Okay, so you it's when they come together or things break apart or whatever. So reactivity is the readiness or willingness of an element to combine with other elements. Okay, so let's get that. Readiness of an element to combine with other elements. All right, now, and they do that to form compounds. You can predict how reactive certain elements are based on their location on the periodic table and their number of valence electrons. So think back to when we color-coded and labeled our periodic table. Remember we said that those over here in groups 1 and 2 were going to be really highly reactive. And over here in group 18, they're not reactive at all. Okay, so, and that has to do with the number of valence electrons. Groups 1 and 2 only have 1 or 2 valence electrons, whereas group 18 has 8 valence electrons. And you're going to see why that's so important in just a second. All right, so let's go ahead and highlight location and valence electrons, number of valence electrons. Those are the two things that kind of drive how reactive atoms of an element are. Oops, okay. So next, you have a table on your note sheet that you need to complete, and it should be very easy because we learned this when we labeled our periodic tables. We know that any of the elements in group 1, they're going to have 1 valence electron. Group 2 has 2. And then we skip the transition elements and the transition metals in the middle. And then group 13, we said it doesn't have 13 valence electrons. It has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And 18 has 8. So make sure you fill in that table on your note sheet. Okay. Now, let's erase this real quick. So stability, okay, so reactivity and stability are going to be closely related because that reactivity depends on whether or not the atom is stable. All right, so with the exception of just a few elements like hydrogen, helium, and lithium, most elements are going to need 8 valence electrons. Okay, now valence electrons are the electrons in the outermost energy level. Well, hydrogen, helium, and lithium only have 1 energy level. So they really only need 2 valence electrons to reach stability, whereas most atoms are going to need 8 valence electrons. All right, so let's highlight real quick the requirements for stability. So let's say most elements require 8 valence electrons to achieve stability. And I would even go so far as to circle the word 8, okay, because that's just really important. That's like the magic number when it comes to stability of atoms. Okay. So most elements, they're going to bond with other elements in order to fill those outer energy levels and become stable. So that's one of the things that they will do in order to reach that magic number of 8 and to become stable. So they bond with other elements to fill their outer energy level. Okay. All right, now the group 18. Remember, we said that it has 8 valence electrons, so it is stable. It is not going to be reactive. So group 18, we call that the noble gases. They have 8 valence electrons, and we want to highlight that they do not naturally form compounds. So they are not very reactive at all. All right, hopefully everybody's pretty clear on what we've got so far. So we understand that reactivity is based on the number of valence electrons. Valence electrons are the electrons in the outermost energy level of an atom, and 8 is the magic number for most atoms. If it has 8 valence electrons, it's going to be stable. It won't bond. If it has less than that, it's going to try to bond with other atoms. Okay, so moving on. So the 3 types of bonds, we have ionic bonds, covalent bonds, and hydrogen bonds. Now, ionic and covalent bonds are related in the fact that they're all about filling that outermost energy level, getting that magic 8 valence electrons. Hydrogen bonding is not about that. Hydrogen bonding is after molecules are already formed. So covalent bonding has already occurred, and you've got 2 molecules, and then they bond together. That's hydrogen bonding. So first, let's start with ionic bonds. Okay, now ionic bonds are going to be between metals and nonmetals. So that's really important that you remember. So let's highlight metals and nonmetals. Okay, so what happens is the metals, like in groups 1 and 2, they only have 1 or 2 valence electrons. And then the nonmetals, like the ones in group 16 and 17, they have 6 or 7. So they won't. Neither of those are going to be happy because they don't have the right number of valence electrons. So they're going to bond with each other in order to get that right number. Now, with ionic bonds, the bonding that occurs happens because of transfer of electrons. So you're going to see that metals are going to give electrons away. They're going to give 1 or 2 electrons to the nonmetal, and then the nonmetal takes on those electrons. So it's all about the transfer of electrons. So electrons are transferred from one element to the other, and this forms ions. Now, ions are atoms with a charge. Okay, so think about it. We learned that atoms have an equal number of protons and electrons. Well, if an atom gives an electron away, then now it's going to have less negative particles, more positive particles, and so it's going to become positive. It's a positive ion. Okay, whereas the atom that gets an extra electron, so if it gains an electron, it now has more negative particles than positive, and it becomes negatively charged. So think about, what do opposites do? They're attracted to each other. Okay, so your positive and your negative particles are going to form a bond of attraction. Okay, where they're those oppositely charged ions are attracted to each other. Okay, so I think that's basically what I've got in this next slide here. So ions are atoms of elements that have a charge. That's definitely something we want to highlight. Ions, atoms with a charge. And then positively charged ions, we call those cations, okay? And these are when they give an electron away, and so they become positive. Whereas negatively charged ions, we call those anions, okay? And that just kind of sounds negative. So anions, and they actually receive or take electrons, so they become negatively charged. Okay, so that's ionic bonds. All about transfer between a metal and a nonmetal, and one atom is giving electrons away, the other is taking electrons, and so they become positively and negatively charged, and that is what attracts them to each other. Now, the next type of bond is what we call a covalent bond. Oh, sorry, last thing. The attractive force between the positive, I already said it, but anyway, the oppositely charged ions is what holds them together. Okay, so this picture just shows an ionic bond. So I want you to look at it, and I want you to try to figure out how, if you saw this picture, how would you know that it was an ionic bond? Okay, well, what I see, first of all, is I see that one electron from the sodium atom is being given to the chlorine atom. So when this sodium ion loses that electron to the chlorine, it now has only 2 energy levels, and its second energy level is full, so it's happy. Chlorine now has 8 in its third energy level, so it's happy. And then we know that when sodium loses that electron, it becomes positive. Chlorine, when it gained it, became negative, and so now they are attracted to each other because of those opposite charges. Okay, so this is a ionic bond. All right, so next is covalent bonds. This is going to be between nonmetals. Okay, so definitely want to know that. Only between nonmetals. It forms molecules. Okay, so that's what we call, when you have different non-metal elements that come together. Okay, that's a molecule. And it's all about sharing. So you don't have one atom giving an electron to the other. Instead, they are sharing electrons to fill those outermost energy levels. Okay. Now, when atoms share one or more pairs, they form covalent bonds. Okay. And then we want to make sure that we understand that sometimes they're shared unequally, and we call that a polar molecule. So it's sort of like a tug of war. You're going to have some molecules where atoms are larger than others that are forming that molecule, and they are going to pull all the electrons toward their end of the molecule and give it a slightly negative charge, leaving the other end slightly positive. That's a polar molecule, like water. Water's a polar molecule. So we just want to say that one atom pulls the electrons closer to its nucleus. Oops. Oh, didn't even know we did that. Okay. And that's going to result in a negative charge. And then the other end would have a slightly positive charge. Oh, there we go. Okay. So that is polar. Polar is unequal sharing, whereas nonpolar is when you have equal sharing of electrons. So you may want to highlight equal, shared equally is going to be nonpolar. And we'll talk a little bit more about this when we talk about water. Okay, so let's go ahead and move on. The last type of bonding that we want to talk about, or real quick, how can we know this is a covalent bond? Each one of these is covalently bonded. We've got water, ammonia, methane. So this methane molecule here, the hydrogens and the carbon are all covalently bonded, and you can tell because they're overlapping. Those energy levels are overlapping, and they're sharing those valence electrons, so that each hydrogen atom has 2 valence electrons, okay, because it only has 1 energy level, so they're happy. And then carbon has 8 in its outermost energy level, okay. Same thing happening over here with ammonia and then with water. So you can tell there's no positive and negative atoms, and there's overlapping of the energy levels. So that's covalent. All right, the last type of bonding that we want to talk about in this video is hydrogen bonds. And remember what I said, this is not about filling those outermost energy levels. This is a bond that forms between molecules that are already made. So here, what we want to highlight is that it happens because there's a slight positive and negative charged ends on polar molecules. And so then the polar molecules can bond with other polar molecules through hydrogen bonding. So you got that slightly positive end of one molecule, slightly negative end of another molecule, and then they're going to form a bond with each other. It kind of reminds you of ionic bonds, but this has nothing to do with filling those outermost energy levels. Okay, so the bond that's formed here is going to be a real weak attraction. So it's going to be the weakest. The ionic bond is extremely strong. And covalent bonds are strong, but ionic is the strongest, then covalent, and then hydrogen. Okay, and the slightly positive hydrogen end of one molecule and the slightly negative end of another molecule are going to be attracted to each other, and that's where that hydrogen bond forms. Okay, this is not working for me. Let's try this again. I'll go this way. There we go. So this would happen like between water molecules. You would one water molecule, the positive end of one water molecule and the negative end of another water molecule would be bonded together with a hydrogen bond. Okay, and here's a picture showing a hydrogen bond, and actually this is two water molecules. Here's one. This is your oxygen and your two hydrogens. Hydrogen end is positive, oxygen end is negative. Over here, this is also a water molecule, just in a different, it's turned differently. But your oxygen is negative, hydrogens are positive. So the oxygen end of one water molecule and the positive hydrogen end of another are attracted to each other, and a hydrogen bond forms between them. Okay? All right, I think that's pretty much it. There is a chart that you will need to fill in on the back, and you would use your notes to help you complete that. And then you can check Schoology, and I should have a resource for you to check your work and make sure that you've got that filled in correctly. Okay, see you next time.